Good evening, ladies and gentlemen. How's everybody tonight? Good. Thanks for coming out for this, February edition of our 2009 Von Karman Lecture Series. As some of you may know, the United Nations Educational, Scientific, and Cultural Organization has chosen 2009 as the International Year of Astronomy. What makes this year so special is that 400 years ago, in 1609, Galileo Galilei first turned his telescope towards the stars and reported back on what he saw. His humor, passion, and blunt honesty gained him instant fame and plenty of trouble. Tonight we'll journey into the past to see what he saw and learned why it caused such an uproar, and we'll take him along on a journey to show him how we're continuing his work and see what he would think of the discoveries we're making with the telescopes of our age. Tonight's speaker is the manager of the Office of Education and Public Outreach at the Spitzer Science Center at the California Institute of Technology. Originally from Wisconsin, she obtained a bachelor's degree of astrophysics from Harvard University, and in 1997 obtained a PhD from Georgia State University. In fact, some of what she learned and did while in school helped lay the groundwork for detecting planets around other stars. She's published over a dozen journal articles and contributed more than 24 papers to various conference series. She's also a nationally recognized spokesperson for science and astronomy, having appeared in numerous documentaries, as well as regularly hosting the program The Universe. On top of that, she produces and stars in several podcasts, some of which have received the highest honors for web work, and she is a nationally syndicated columnist for the Christian Science Monitor and has written articles for Sky and Telescope, Discover, Mercury, and Engineering and Science magazines. Within NASA, she has served on several review boards and evaluation teams working to make NASA's educational programs as effective as possible. Obviously then, working with teachers and students has been a major focus of her career. And in 2005, she started the Spitzer Teacher Research Program, where as part of this program, over 50 teachers and hundreds of students have used the telescope to make their own original observations, the results of which have been published in the Astrophysical Journal and the Bulletin of the American Astronomical Society. And the list literally goes on and on and on and on. So in an effort to reduce my time up here, I will just now introduce our guest. Please join me in welcoming Dr. Michelle Thaler.
Oh, well, welcome. We're obviously doing something a little bit different tonight. For those of you that know my science work, tonight we're celebrating the 400th anniversary of the telescope. 1609 was when Galileo actually began his observations, the very first telescope ever. And I decided we might as well get into the spirit a little bit. So I'm dressed in the latest 1609 fashions. I've researched this, so I'm enjoying myself. Galileo is a fascinating character to me. In some ways, he seems very modern. He was a very good publicist. He actually valued education. In some cases, he published his works in Italian, the language of the people, versus Latin, which the scholarly works had been published in before. He also ran afoul of a lot of politics. And there seems to have been kind of a bad point in history where, unfortunately, the church was taking sides. There were the Protestants and the Catholics. And at this time, that argument was a very, very violent one. People were getting killed. And Galileo's problems really stemmed from that time. So what I'd like to do tonight is I'm going to start by giving you sort of an overview of Galileo's life. After that, I want to show you exactly what he saw through his telescope and why it was so important. And then we'll look a little bit on and see actually, some of the spacecraft. A lot of you have been into the museum where we have the Galileo model. Talk a bit about the spacecraft that bears his name. Okay, so with that in mind, Galileo, 400 years of the telescope. Oh, here we go. Now, these are sort of the salient points of Galileo's life. The interesting thing about Galileo is his first name. I think most of you probably know that. This is the famous astronomer George. I mean, it's somebody that we call by their first name. Of course, his actual name was Galileo di Vincenzo Buonatucci de Galilei. So Galileo Galilei was his actual name. I don't know whether that was considered funny at the time or not. It's sort of an odd-sounding name. Born in 1564, he was actually the child of a famed lutenist, somebody that built lutes and was a very good music professor as well. In 1589, he was actually at the University of Pisa, and then he moved on to a slightly larger university in Padua in 1592. We'll talk a little bit about his family life, and there's been some fascinating work recently on his family, specifically one of his daughters. He fathered 3 children with a woman named Maria de Gamba, and none of the children were legitimate, and at that time, that was somewhat important socially. It's not that people didn't have legitimate children, but the fact that children were not legitimate changed their lives. So it's an interesting story about what his daughters became and what happened to them. Now, in 1609 is when we know he began observing with a telescope. Telescopes have been around for a while. They've been used at sea, mainly by the Dutch. But, I mean, it shouldn't have taken long for somebody to get the idea to point one of these things in the sky. And another thing about Galileo, he was very much at this cusp of history. Everybody had gotten these newfangled spyglasses, and many people were beginning to tilt them upward. He was not the first one necessarily to use a telescope, but he was a very good publisher. Those of us in science understand that if you make a discovery, it doesn't count unless you publish it. And he was one of the fastest publishers, one of the best publicists of his work. Then things got a little bit more difficult for him. In 1610, he published The Starry Messenger. And we'll talk a lot about what the different observations were in there. In 1613, a letter on sunspots. Now, later on there, in 1616, was when he started to get in trouble with the church. And at first, he was just admonished by Cardinal Bellarmino, who was the chief inquisitor. After that, things got a little bit stickier. He kept publishing. In 1632, went to trial for heresy. And in 1634, was put under house arrest for the rest of his life, and he died there. So we'll talk about what the politics were. Why were Galileo's observations so controversial? And what was it about this time in history that made that so? All right, now you mentioned his family life a little bit. This is one of his daughters, Suor Maria Celeste. And he had two daughters named Virginia and Livia. This was Virginia before she became a nun. And as I was saying, illegitimate daughters were a bit of a liability at the time. There wasn't socially much you could do with them. The two were put in a convent of the Poor Clares in Arcetzi. And there's a fascinating book that's been written on it called Galileo's Daughter. I know the author, Davis Sobel, and I really enjoy working with her on this. The neat thing about this woman is that Galileo saved all of her letters. So we have this conversation. We have the actual letters that he wrote to her. The unfortunate thing is that her letters were not kept so much. She was actually a nun, and the convent burnt everything she had. So although we have the letters that Galileo had that she wrote, Galileo kept those until his death, and they're now published. We don't know what he wrote her, because everything she had as a nun was burned when she died. So it's a one-sided conversation, but a fun conversation at that. Just to sort of show you that things were a little bit messy back then, that little chart you see to the end there is a horoscope that Galileo cast for her. There was really very little difference between astronomy and astrology at this time, and Galileo did a little bit of horoscopes on the side there. All right. Here's my laser pointer. Now this is what caused all the trouble with Galileo, the idea that the Earth is in the center of the universe. It seems the most obvious thing to us. The Earth is stationary, we're not moving, and this is the way that people had set things up, with the Earth in the middle, and then in sort of concentric spheres were the orbits of the Moon, Mercury, Venus, the Sun. Even then it was understood that Mercury and Venus must be a little bit different. Their orbits were not the same as the other planets. And then we go on to Mars, Jupiter, and Saturn. And of course, at this point, Uranus and Neptune had not been discovered. So this is the universe the way it was presented academically. The interesting thing is that not everybody, even in ancient times, accepted that the Earth was the center of things. This universe is called the Ptolemaic system. And Ptolemy was a Greek astronomer from about 85 to 165 AD. And as you can see, this diagram is from one of his works. And he's responsible for something called epicycles, which was a big part of the geocentric view of the universe. And I'll show that in a sec. When you observe a planet like Mars, if you observe it against other stars in the sky over some time, it appears to do a little loop. And it appears to sort of be going on. So see, here's a 517, so it's sort of going this way. It actually loops backward on itself. And that motion was difficult to account for, because in nature, when you throw something, when you drop something, it goes in one direction. Things go down, things go forward. It's not natural for us to throw something and have it stop and go back and forth and continue. So retrograde motion was difficult. The way Ptolemy described it is that planets must be on these little circles, epicycles. And as they went around the Earth, here's the Earth in the center. As everything goes around the Earth, the planets are also moving on these little wheels, and that causes that retrograde motion. So this is how the Ptolemaic Earth-centered system dealt with retrograde motion. Now I want you to notice here, okay, here's the Sun, here's the Earth. Remember I said that Mercury and Venus are a little bit different? Ancient astronomers observed that neither Mercury nor Venus ever get very far away from the Sun. You never see the Sun in a totally different part of the sky as Venus, for example. So they had a line drawn from the Earth to the sun, and Mercury and Venus went around attached to that line. That's going to be important because some of Galileo's observations directly showed this could not be true. So remember that. Remember that line. Now, it's worth mentioning that even the ancient Greeks had better explanations for retrograde motion. There was a man named Aristarchus of Samos, which I'll talk a little bit more about. Aristarchus put the sun in the center. And he said that if you put the sun in the middle of the solar system and all the planets go around the sun, including the Earth, then you don't need to have any weird little epicycle. The only thing that's happening is as the Earth orbits by, as it passes Mars, if you're on the Earth looking at Mars with respect to the distant stars, you see it against some background stars here, against different background stars at this part of the orbit, and then when you're past, you see it against different stars again. And that's all you need to make it look like Mars goes backwards. So with a sun-centered system, you don't need a silly little epicycle. All you need is that when the Earth passes by Mars, it's a lot like when you pass by a car on the highway. You're both going forward, both you and a car next to you, but as you pass the car by, you see the car appear to go backwards relative to the background. So already the Greeks had figured out that this might be a better way to deal with the motions of the heavens, putting the sun in the center. They also were really smart. I really, really love Aristarchus. One of the things that he reasoned, why should the sun be in the center? It's obvious to us the Earth is not moving, we're still. So what caused him to think maybe the sun is the center? Well, he was really amazing. He looked at lunar eclipses. And if you look at a lunar eclipse, and this is actually a time-lapse picture, this is right where the shadow of the Earth begins to block the moon, and then the moon moves through the shadow. Aristarchus realized that this curve was the shadow of the Earth. And if you look, there's light being cast on all sides of that shadow. You can only see it where it hits the moon. But there's light being cast around in this direction and also around in that direction. That means that whatever is casting the light is bigger than the Earth. You see that? It's actually that obvious if you think about it. If you think about the Earth casting a shadow and the fact there's light all the way around, whatever's casting the light has to be the larger object. And why would the sun, if it's larger than the Earth, be going around the Earth? Shouldn't everything be going around the larger object? Amazingly, the ancient Greeks put the sun in the center thousands of years ago. And just a little bit more about Aristarchus. Like I said, I'm a big fan of his. This is a statue of Aristarchus in his hometown of Samos. And Aristarchus was working about 200 BC. So, we're dealing with something a little bit more than 2,000 years old now. Aristarchus was also the person that showed what the circumference of Earth was. He was the first person to measure that. And this is something I've had trouble with being a science educator, because I was once doing a television program for the Discovery Channel, and they said, we want you to explain how Columbus proved the Earth was round. That is a complete misconception. The ancient Greeks knew the Earth was a sphere. And even the Earth-centered people, the Earth-centered system, had Earth as a sphere in the center. Columbus did not prove that the Earth was round. We knew that. Aristarchus measured how far around the entire Earth is, and again, in a ingeniously simple way. There was a well in Syene, a city, and Syene happens to be on the Tropic of Capricorn. The sun actually passes directly overhead one day of the year. And he noticed that on that day, the sun would shine straight down a well at this city called Syene. Now, Alexandria, which was a couple hundred miles away, he noticed the sun was not shining directly down the well. He took the angle the sun was away from overhead, and he figured, okay, that angle, that little bit of angle that the sun is away from overhead, I'm going to take that and assume that that's part of 360 degrees, a whole circle. And then the distance between Syene and Alexandria must also be the same proportion of the whole circle around the Earth. He got it exactly right. So the ancient Greeks knew that the sun was in the center. They knew the correct circumference of the Earth. Somehow all this stuff got lost, and that's where a lot of political problems got started. Namely, this person. Nothing against St. Thomas Aquinas, but all of the knowledge of the ancient Greeks was lost to the West. During the Dark Ages, we actually didn't know about Aristotle or Plato or any of the ancient Greek astronomers, none of that. We rediscovered that knowledge during the Crusades. When people invaded the Middle East and all of that scholarship was kept by the Muslim leaders in the Middle East, we rediscovered this. And during this time, shortly thereafter, Thomas Aquinas really fell in love with the teachings of Aristotle. Aristotle had this wonderful, elegant view of the universe. Everything should make sense. Everything should be perfect. The sun is perfect. The moon is perfect. The only thing that is imperfect is Earth. And the only thing lower than Earth is hell. So, we basically are sort of just above hell, and the heavens are absolutely perfect. This got put into Catholic doctrine, and for 1,000 years really wasn't questioned. Okay, then comes Copernicus. Now, Copernicus was a Polish cleric, and he also began to realize that even if you just think about it, if you just make some good observations of the heavens, it doesn't make much sense to put the Earth in the center. Especially with the epicycles and the retrograde motion, things work a lot better with the sun in the center. And so he published his works, notably very close to the time he died. I think he was a little bit worried about getting in trouble for it. But when I was doing research for this talk, one of the things that I found is that the idea that the Catholic Church was necessarily against a heliocentric, sun-centered universe wasn't really true, that there was a lot more debate going on. It was hardly monolithic. In fact, there was a letter from the Archbishop of Capua where he said, "With the utmost earnestness, I entreat you, most learned sir, to communicate this discovery of yours to scholars and at the earliest possible moment to send me your writings." The Catholic Church was not a monolith. Not everybody in the church was against this view of the heavens. The problem was one of politics. Things were about to get very messy between the Catholics and the Protestants. In the 1600s, you had massacres happening. There was the St. Bartholomew Days massacre, which was in the 1570s. Thousands of people were killed over this. Unfortunately, Copernicus, or fortunately, depending on what side you were, Copernicus was Protestant. The fact that Copernicus was Protestant meant the Catholics shouldn't like him. And that set off a lot of grievances. People for a while realized that the Earth-centered system wasn't working, but boy did they try. They really tried to hang on to it. This is an astronomer named Tycho Brahe. Tycho Brahe was working before the telescope. He only had the ability to measure very accurately the angles the stars were in the sky. He didn't have a telescope at all. He actually began to realize that retrograde motion didn't work if you had the Earth in the center. The way he proposed to solve this is kind of cute, this is the Tychonic system. He had the Earth in the center because philosophically he thought that was best, and the moon goes around the Earth. And then he said, what if we have the sun and all the other planets go around the sun, and the sun goes around the Earth? Yeah, they were trying hard. Yeah. There was a philosophical need for this Earth in the middle. It didn't match observations. People were doing everything they could, including bending over backwards. I mean, this is a brilliant man, but he could not let go of that idea that you really should put the Earth in the middle. It's hard. And there's Kepler, too. Johannes Kepler was a student of Tycho Brahe's, and Kepler was actually writing the same time that Galileo was writing. We know that probably the earliest recorded correspondence we have is 1596. So Kepler, as a Protestant cleric, well, I shouldn't say cleric, he did study for the priesthood, but as a Protestant professor, he assumed the sun was in the center. No argument. It worked better, it got rid of epicycles, everything was simpler. So just sort of across Europe, at the same time as Galileo, there were royal courts, there were academics that did not question the sun was in the center. But somehow Italy, trying to maintain its independence, trying to make sure that the Catholic Church was separated from these dangerous Protestants, decided to hold on to geocentrism. Also, one of the things that I do, the reason I have these lovely clothes, is that I actually portray the court of Elizabeth I in some Renaissance fairs nearby here. It's kind of a hobby of mine. And Queen Elizabeth had an astrologer. He was sort of an alchemist. He was a very odd man. He used to be able to see angels in a crystal, and he would tell Queen Elizabeth what they said. I mean, interesting definition of a scientist. This actually passed for sort of the science advisor of Queen Elizabeth I. They openly discussed heliocentrism. And I think it's on record that Queen Elizabeth was skeptical, but John Dee actually liked the idea of the sun in the center. What I'm trying to show you here is that it's a myth that at the time of Galileo, we didn't know the sun was in the center. Galileo's problems stem a bit more from a political argument that was ill-timed. Once we had the telescope, there was no longer any argument. The observations that Galileo did proved without a doubt that the Earth in the center just doesn't work. There were courts all over Europe that already accepted the fact that the sun was in the middle. So I think that kind of puts an interesting light on what happened to Galileo. He was sort of in the wrong place at the wrong time, historically speaking. Now, Galileo as we said, probably did not invent the telescope. It was sort of based on Dutch spyglasses. This is actually a diagram of Galileo's telescope, sort of a simple one that he first came up with, and a more complex one a little bit later. These, I actually have had a chance to look through a telescope that's designed with the same optics, and a good pair of binoculars will give you a better view of the night sky. So when we talk about the advent of the telescope, remember, at first, it was a very simple instrument, only magnified by a factor of 10, maybe 20 or 30 at the best. And how many of you have actually taken binoculars and looked at the night sky, though? It changes immediately. As soon as you put binoculars and you look through them, you see stars you couldn't see before. Everything looks different. So this amazing new advent that we're celebrating the 400th year of, it was a simple piece of optics. So it's a crappy little telescope, but it revolutionized everything. Now, Galileo, as I said, a very good public relations person, he realized that the telescope had more practical uses than looking at the sky. And the first thing he did when he had a good working telescope was he went to the authorities in Venice. This is the Piazza San Marco. And he actually placed a telescope at the top of the Piazza San Marco, and you could sight ships coming in to Venice, very important for Venice. There were two reasons you might want to do this. One, you could actually sight enemy ships long before they came in. But there was also a more capitalist reason, right? We're good Italians here. And if you could sight a merchant ship coming into harbor, then you could do a little speculation. You know, if you saw a ship carrying wine, okay, I recognize the colors of that ship. That's a ship carrying wine. I know the captain. I'm going to start buying up wine at a cheaper price or something like that. They were used for speculation. So this was so useful to Venice that Venice decided to put Galileo on a salary. They actually gave him money for the rest of his life just for that one accomplishment. But unfortunately, Galileo really didn't stay there. He decided to do some other things. This is an interesting, again, a misconception about Galileo. You probably have heard that Galileo dropped weights off the Leaning Tower of Pisa and things like that. We actually don't have any records of that. And Galileo was enough of a publicist that we have a lot of records of what he did. We do know that he went to the top of the tower in Piazza San Marco and showed people through the telescope that they could see the ships coming. There's some earlier telescopes. I was recently at the Aglo Planetarium in Chicago, and the care put into these was just beautiful. The colors, the paper, the embossed leather, the way it telescopes out and the tubes expand. It was wonderful to be able to hold some of these. They're incredible instruments, a little bit more delicate and decorated than our telescopes today. Now, as I mentioned, Galileo wasn't really the first person to observe these things. We know that there was an Englishman, Thomas Harriot, from 1600 to 1621, 1560 to 1621, and he probably made the better maps of the moon than Galileo. The problem was he was not a very good publisher, and he didn't have the patronage of the royal court the way that Galileo did. So his works just were not widely distributed. But this is an actual reproduction. Everything that I show you that looks like a reproduction is from the manuscripts directly. It's wonderful what you can find on the internet these days. And his maps of the moon are much more accurate and in some ways much more of a detailed, great all-moon maps, better than Galileo made. So there's a map of the moon done by Thomas Harriot. And of course, Galileo started seeing some very interesting things, not just the moon, he also observed sunspots, which we'll talk about. And in this is actually a notes from Galileo's notebook. Down here is sort of the neat part. He began to observe the moons of Jupiter. And observing the moons of Jupiter convinced him that there were things orbiting the planet Jupiter. That kind of goes against the idea of the Earth being the center of everything. If moons can orbit Jupiter, then the Earth really isn't the center of all rotation. The reason I show you this particular page is that this allowed Galileo to get some great patronage. He was always thinking, how do I get money? How do I get patronage? And the Medici family was very powerful at the time. You know, they were the real power in Florence. He knew that if he could get in with the Medicis, he was doing well. Now, at the time, the Grand Duke of Tuscany was called Cosimo de' Medici. And Cosimo was one of 4 brothers. So he saw these 4 stars orbiting the king of the gods, Jupiter, and he thought, aha, there's 4 brothers, the Medicean brothers. Let me write to them about this incredible discovery of 4 stars that orbit the king of the gods, just like they orbit their illustrious father. Yeah, I mean, he did. I mean, he was really, really good at sucking up about things like that. Yeah. Galileo also observed sunspots, and again, we actually have better sunspot drawings and observations from different people. Oh boy, I forgot to put down who wrote this. I'll correct that later on. But this is from another astronomer at the time, a lot of detail on the sunspots. So although Galileo was making observations, as I was saying, this was a discovery period whose time had come. we had these new spyglasses. Everybody and their brother was thinking about turning them up to the sky. It's just that Galileo knew that that was true, and he was fast. He was ready to move on that. Okay, Siderius Nuncius, then, is the place where he began to publish what he was actually observing. And it was here that he mentioned the Medicean stars. See that? Medicia Sidera, Medicean stars. And this was one of the first times that he had all the patronage he wanted. The royal court was very favorable to him. And so in some ways, this was kind of his golden age when he began to publish this. And as you can see, there's the crest of the Medicis. The Medicis, like I said, were the main power in Florence. And so Galileo moved over to Florence to actually be a part of their court. This is Cosimo de' Medici. Unfortunately, he lived a relatively short life. I managed to find a baby picture of him. Very nice. And this is actually a posthumous portrait of his wife and his son. His son, he actually died when his son was still a child, but his son did succeed him into the dukedom. So there was Cosimo, and Cosimo was a happy patron, and Galileo was in this glittering court of the Medicis. As you can see from some of the ruffs that people are wearing, this is not an exaggeration. I think, if anything, people wore larger ruffs than this. Pretty incredible. And there's Florence. What an amazing center of learning to be in. Now, the problem with Florence, up until this point, Galileo had been in Padua, and Padua was under the control of Venice. We mentioned the Piazza San Marco. Venice had a real independent streak. It wanted to be a little bit separate from all of Italy. It was an independent kingdom. Florence was much closer to Rome in many ways, politically. You know, people who were big people in Florence often became pope. Florence was much more under the control of the Vatican. So although Galileo had this wonderful new patronage, he also had a lot more eyes on him and what he was saying. So here he is. He published another letter, his sunspots, and this is an actual frontispiece of the book. That's the cheesiest looking smile on a woodcut I've ever seen. I mean, he's like, hey, look at me, I'm Galileo. It's wonderful. I love that. And he really was very happy, very, very arrogant, wonderfully, being in science, I have to deal with a lot of egos, a lot of strong personalities, and Galileo just fits right in there. He was a great self-promoter. So there we have some, again, he dedicated it to Cosimo. So everything he did, he wrote these wonderful introductions about how wonderful the Medicis were and how wise they were to support him and how they should continue to do so. All very good stuff. Now, not all the Medicis were buying this. And it's worth saying that there was a very significant woman, the Grand Duchess Christina. The Grand Duchess had some real objections to what Galileo was saying. And she thought that Galileo was contradicting the Bible. Specifically, there is a scene where Joshua commands the sun to stand still in the sky so a battle can continue. And she wrote to him and said, how can this be if the earth is moving? If we're in the center, then perhaps Joshua could say to the sun, sit still. But how would that work if we were going around the sun? Galileo wrote, what in many ways is my favorite part of his writings. He wrote this very, very well thought out letter, a response to why Scripture is sacred, but at the same time you cannot deny your senses, you cannot deny your observations. And he came up with a very good argument that if Scripture and observations seem to contradict each other, the error must be a human one. It must be with us. It must be with our interpretation of Scripture. So there was a time when literally people did not believe that the earth moved, and they thought the Bible backed this up. Today, we interpret the Bible differently, and we don't think that's a contradiction. And Galileo was trying to say that that mistake is with humans, not with God. That kind of worked. Unfortunately, Cardinal Bellarmine, the Grand Inquisitor, was put on Galileo's case. And Galileo had reason to notice this man. Now, at this point, I did not think that Galileo was scared. But it's worth noting that this was the man that helped condemn Giordano Bruno, who advocated a sun-centered system and had him burnt at the stake in 1600. Now, Giordano Bruno was a lot of trouble besides the heliocentrism. He actually was somewhat of a New Age pagan type. He was sort of a pantheist. He denied the divinity of Christ. So perhaps in the Cardinal's defense, there were other reasons to get rid of Giordano Bruno. But Galileo knew that there were some pretty serious consequences for going against this person. And under Pope Paul V, Galileo was warned pretty seriously not to advocate that the sun was in the center. Now, Galileo was very confident, and he also was a very good, strong Catholic. He believed he had God on his side. He did not think he was contradicting the Bible, and he set off to the Vatican. with every intention of convincing them that he was right. And in fact, the Jesuit astronomers in the Vatican really liked what he had to say. So even the Vatican had factions, people that agreed with Galileo and people that didn't. It's also a misconception that people did not believe what Galileo saw through his telescope. I've heard that people said, oh, you're looking through a little glass tube, I don't believe what you see. The Vatican astronomers got those telescopes very quickly, and they were able to confirm everything Galileo saw. So Galileo had a lot of friends at the Vatican. And even more so, things got even better for him. When Pope Urban the VIII was actually ordained, it's probably not the right word, the man had been Maffeo Barberini, and he was a close friend of Galileo's. The two were actually very good friends. When this man became Pope, Galileo and him would walk through the gardens of the Vatican together having discussions. So it really was a wonderful time for Galileo. He had the Pope's support, and he actually published this little letter called The Assayer. And in it, he did everything he could to please the Pope. Among other things, the Pope had a little bit of a fight with Jesuits going on. And there were Jesuit astronomers that believed that comets were very far away, farther away than the moon. And Galileo wrote this Assayer making fun of that, saying that can't possibly be true. Okay, for those of you today, are comets farther away than the moon? We sure hope they are. Yeah, otherwise we're in real trouble. So this was actually a pamphlet written by Galileo that the astronomy was completely wrong. And he actually sort of blinded himself to some very good arguments made by the Jesuits. So there's the Assayer again. Like I said, a little bit of a misstep there. But then Galileo, confident that the Pope was in favor of him, took a step further. And he wrote this book, and this is what got him in trouble, the Dialogues. The Dialogues concerning the chief world systems had 3 characters. I mean, this was amazing. This was not a formal Latin discourse. This was actually a work where there are 3 characters talking. They're at somebody's garden, they're having a discussion. And one of them is advocating the sun being the center of the universe, and one is advocating the earth. Now, Galileo could never do a subtle argument, and so the person who's arguing for geocentrism is called simplicio, the simple one, the simpleton. And what happened is that some people talked to the Pope. The Pope may never have read this, and they told the Pope that some of the arguments the Pope had made for why geocentrism could be a good model, maybe heliocentrism was just a theory, the very same words had appeared in the mouth of Simplicio, so Galileo was making fun of him. That may or may not have been the case, but it did the trick. The Pope reacted very angrily, and Galileo was brought to trial. He was forced to recant heliocentrism and was actually put up before the Inquisition. There's a legend that as he was recanting, as they pulled him up, this old man now, he muttered under his breath, and yet it moves. Again, it's a legend. There's no actual record of that. And all I can say is that, judging from Giordano Bruno, Galileo would have been pretty stupid to do that. If you're in front of the Inquisition, dressed in the white robes of a penitent, say what they want you to say. And so he was banished to house arrest, and there he died. He did have students throughout his late life. He eventually went blind. He had actually eye trouble through most of his life. But this is actually a picture from Galileo's house where he was under arrest, looking back on the city of Florence. So that is, in short, the story of Galileo. And here's his tomb in Florence. I have had a chance to visit it, and it was wonderful to actually be there. The beloved daughter, the Sister Maria Celeste, is buried with him. So the two were actually close. She unfortunately died before him by quite a long time. Okay, so that is the end of the first part of the talk. I told you I would give you an overview of the life of Galileo, talk a bit about the politics, a bit about why he got in trouble. Now what I'd like to do is actually talk about the real observations, what he saw. And we're going to talk mainly about what he saw in this book, Sidereus Nuncius. And I want you to notice at the bottom, this is actually a signed copy of the book that was scanned in. That really is his signature on the bottom there. This was given to a poet, a courtier in the Medici court. So Galileo, when he was popular, was signing copies. It was just great. Okay, so how should we do this? How should I show you exactly what the observations were? Well, if you permit me. For those of you that have been to my lectures before, you know that I have a bit of a mistrust of linear time. Time can be many different things. There are many different possibilities. And so tonight, I'm here, I've dressed the role. I thought I would bring out a special guest, and he will tell you about his observations. So ladies and gentlemen, may I present to you Galileo Galilei. Signore. Padrone. He has come a long way. He just got my invitation very, very soon, so unfortunately he hasn't had a chance to prepare much. But I thought you would enjoy hearing about Galileo's observations from the horse's mouth.
Grazie. Reclaram sane atque humanitatis penmeorum fuit incitatum. Cui excellantem virtute...
Elissimo, perdono, padrone.
Che cosa?
Non parlano il latino.
State scherzando?
No, padrone.
Nessuno di loro?
No, padrone.
Italiano?
Italiano? No, padrone.
Che lingua parlano?
Inglese.
Inglese. Così. Sono fra i bavari. My lords and ladies and good gentlefolk, greetings to you. I must apologize for my host, who did not inform me before coming here that while I am sure you are all of excellent breeding and character and have many virtues, apparently the education in this country is somewhat lacking. Even so, I shall in my way try to amend this, and hopefully the marvels which God has seen fit to give to me to discover first before any man in history will not be any less so in this somewhat baser language of England. Today, if you will give me your kind attention for this brief hour, I will just take you on a brief journey through my own journey into the truth of God's creation, and will, I think, give good argument and demonstration why these discoveries that I have made in no way contradict the truth of Holy Scripture, which I hold to be as infallible and put as much faith in for my life, my fortune, and my immortal soul, God save. I feel it necessary to repeat. God's Holy Scripture, God's Word, His revealed Word, cannot possibly contradict the observations of God's creation. It is an impossibility. However, since the population of men who can reason badly greatly outnumbers the population of men who can reason well, we daily see the Scriptures interpreted badly, misinterpreted, and misrepresented. Indeed, many academic philosophers and so-called astronomers and scientists take great offense at me for having published these discoveries of mine, as if I had, with my own hands, placed these things in the sky in order to upset nature and destroy the sciences. They do not understand and do not remember that the increase of known truths is to the benefit of a science, not to its detriment or destruction. Yet they will proceed and persist in their attempts to destroy or to silence me, either from some jealousy, whereby their own ideas of physics or the nature of the world, which must, upon close examination and with view to my own discoveries, must be proven to be false, or from some cowardice of the intellect, where they will not release the ideas that they have been taught from youth, though they were written by ancient philosophers long dead, who had not the benefit of Galileo or of his instruments. Pardon me. I must sometimes consult my notes. I was brought here quite suddenly. To begin, I shall first describe the instrument whose perfection I achieved, and through which I was able to discern so many marvels which no man before me had beheld. About 10 months before the publication of my book, Siderius Nuncius, I received many stories about a certain Fleming who had created a device whereby visible objects may be seen and seem to be considerably larger and clearer as if nearby. There were many reports of this most interesting effect, and some people would deny them, some people gave them credence. Some days later, this was confirmed by a letter from a noble Frenchman in Paris, Jacques Padover. I immediately set my course to see how I myself could create such an instrument. Shortly thereafter, I did. Yes. My basis was the theory of refraction. First, I prepared the tube of lead. Permettimi. You can't bend over either. Cannot get good help. I prepared the tube of lead. Or this. And fitted it with 2 glass lenses, plane on one side, and on one side it was spherically convex, and on the other side concave. When I placed my eye closer to the concave lens, objects far away were made to seem considerably closer, some 3 times closer and magnified by 9 times. I then made one which magnified objects as much as 60 times. And then, sparing neither expense nor industry, I succeeded in creating an excellent instrument whereby objects seen with the naked eye through it seemed to be magnified almost 1,000 times. You may applaud. Yes. Quanto interessante. So that's in my drawing.
That's right, yes.
How is that?
Oh, yeah. It's
You
wonderful.
will
Yeah.
tell me later.
I will.
Then I'll make one of my own. You may hold it.
Carefully, yes.
Yes. Let us suppose that the diagram ABCD. Stop that. Unless you tell me how to make one of my own. Let us suppose that the diagram ABCD is the tube. Now, if the tube has no lenses, then E, being the eye of the observer, I'm sorry, I thought people came here to listen to Galileo. Perhaps you should come up here and do it. I can't point.
Pardon. I put the pointer down.
Rays from the object, FG, will freely go through the lines F, C, E, and G, D, E. You will then put in the lens. And the rays, which formerly were freely directed, now become enlarged, or rather, I should say, the focus becomes much narrower. And so, only the light from HI will be included through the lines H, C, E, and I, D, E. Once the differential between the F, G, and HI is known, a simple table of sines will give you the angle between the angle of the refraction. It is a very simple thing, therefore, to make your own lenses, which of course I did, to your own specifications. And so, now I am provided with this excellent instrument. And I set about to use it. Obviously, the benefits of such an instrument are to see ships at sea or any other terrestrial object approaching armies, but those are very obvious. And indeed, the senators of Venezia doubled my pay when I gave them but a demonstration of one of my early ones, which had only an 8 times power to it. But for my purposes, I declined to look at terrestrial objects and instead set my sights upwards. When I looked at the night sky, through the telescope for the first time I beheld marvels. It is impossible to describe the feeling of first seeing things that no man before you has ever seen. The naked eye can only discern so many stars. But when countless, hundreds, thousands, countless numbers of stars previously unknown, new stars, you are seeing, it is beyond the wildest imaginings of ancient philosophers. Molto bene. And so, to give you a slight idea of this, let's see, misfraction. I present some illustration of known constellations and the new stars discovered by me before anyone else. Here we have in the, I had intended to depict the entire constellation of Orion, but I was overwhelmed. Within 1 or 2 minutes of the arc of the night sky, over 500 new stars could be discerned through my excellent telescope. So in this drawing, I have added merely 80 new stars. The ancient stars, which you can see, are, you have colored them. Very clever. As you can see, I put a line around them, made them much more prominent. Those are the known stars. And the other stars are the new, invisible stars to the eyes. I've tried as far as I could to maintain their relationships to each other in the sky, and also to, in some way, denote their magnitudes, their various magnitudes, as you can see. All this, and this is literally but a fraction of what you can actually see. Taurus. In the constellation of Taurus, I depicted the 6 stars, which are known, sometimes 7, but you cannot always see them, which lie within very narrow limits of the sky. Near them are more than 40 more stars, and I have shown 36 of these in the diagram. I have, again, preserved their intervals and magnitudes as far as I could. Third, I have observed the nature. Interessant. I have observed the nature and the quality of the Milky Way. Now, this has been observed through the telescope now so carefully, so completely and with such accuracy, that all former arguments regarding the nature of this heavenly body are resolved. There is no more need for tedious philosophical disagreements about the nature of the Milky Way. It is now shown to be nothing more than a congress of stars, of clusters of stars, endless, boundless, unimaginable, and completely beyond count. And this is not the only such area in the sky. There are other nebulas which turn out once again, once they are seen through the telescope, they are revealed to be stars, clusters of tiny stars, whose either their distance or their weakness of magnitude will make them invisible individually. And yet, when taken together, they are seen as a milky white film, which we had previously thought to be a more dense portion of the ether, which was capable of reflecting sunlight or starlight. But it is stars, only stars. The observations of the fixed stars in the Milky Way are wondrous indeed, closer to Earth, and more telling and instructive for the advancement of man's knowledge and the nature of the universe is that most heavenly body, the bright moon. Hey, Abby? Oh.
Amazing, huh? Yeah. You could have done a lot with that with the Medicis, I'm sure.
Oh, that's a very pretty painting.
It is not a painting. We have captured an image from your telescope, and we have displayed it such.
Oh, you tell me about that later.
I will tell you later. Yeah.
We'll have to do that. The current thought, and that which is held by Holy Church until she listens to me, is that the universe is centered on the earth, that the earth is the center of it, and that it is the lowest object above hell. All celestial objects are perfect and flawless, without blemish or without a feature. This is not so. Once, when viewed through the telescope, the moon is revealed to be hardly without a feature or without any blemish. Aristotle is wrong. See here. I distinguish it into two parts. The lighter and the darker part. Now, the darker parts, the spots which everyone has seen, these I consider to be the ancient spots or the dark spots of the moon. The lighter spots, though, are completely covered with spots. The areas which are light of the moon are completely covered with the spots. It also has mountain ranges whose height I have calculated to be approximately 4 miles. These spots which you see here, grazie. Grazie. This one particularly, this spot, it appears to be a great depression, for indeed the dark portion of it is always facing towards the sun, whereas this light rim here is always facing away on the side of the sun. We see a similar effect in great valleys on Earth, where at the sunrise, before it is too high, the valley is filled with shadow, while the tops of the high mountains are brilliantly lit up with sunlight. So, Aristotle is not right on this and on many things. Now, he was an ancient worthy philosopher. He could indeed have seen what I see. If he had had the benefit of my instrumentation and had seen what I see, then his reason could not have allowed him to hold his former opinion. And so I think it will be with the Holy Church. Let's see, put the small spots, the sunrise. Oh, yes, as I say, the mountains of the moon. See. As when I pointed my telescope at the sun, the first times it was very painful. You could only look at the sun when it was perhaps behind a cloud, or when it was very near the sunrise or the sunset, when the light itself was much weaker. I am actually indebted to a student of mine who invented a very clever and cunning way whereby sunspots can be observed. If you will first train your telescope upon, you train a telescope upon the sun, you set it, and then you hold a piece of white paper to it. You will see a bright disk, which is a projected image of the sun, with all the sunspots intact, in exact location, exact spots, in exact shapes, and so without any eye strain whatsoever, you can make accurate records of the spots of the sun. The explanation for the spots of the sun has sometimes been that they are some intra-mercurial body, some planet. This is, of course, not true, because I have discovered it. If you will watch my sunspot drawings, which I made over the course of about 1 month, you will see the movement over the spots. They move slowly, they move together. They come in and out, change shape. Notice the foreshortening of the spots as they reach the edge of the disk. This is no planet. It is very clearly that they are on the surface of the sun, or they are near the surface of the sun. They cannot possibly be any planetary body. Scheiner, who says that they are, Wessler, who says that they are fools. This is the sun itself. It is the surface. And again, it is not perfect. It is not without blemish. And it is the center of the universe. By watching this, I have also determined the period of rotation of the sun, which is approximately 1 lunar month. And also by observing the difference between the observed rotation of the sun. It is another potent argument, because over the course of the year, it changes in ways that a simple student of geometry can obviously see. Is from our own perspective, as we circle the sun whose axis is somewhat tilted, I think, you will observe the movement of the sunspots differently. Sunspots, method.
Padrone, in the interest of some time, let us go on to your wonderful discovery of the Medicean stars.
Sì. You have got to tell me how you do this. One night when when Jupiter presented itself to me, I noticed that there were 3 stars that were notable not because they were especially bright, which they frankly were, or any unusual quality of them, other than that they were in a straight line right along the line of the, parallel to the line of the ecliptic of the planet. Made note of it, and then the next night, for reasons I do not know exactly why, I returned to Jupiter. These stars were no longer in the same aspect. You see?
Con permiso.
Sì.
No?
Avanti.
Yeah, it's okay. I can continue.
Yes. You see, you start out with 2 to the east. Then you have 2 to the west and 1 to the east. Then all 3 to the east. And then further, and so on, and so on, and so on. At first, my thought was, is it possible that the planet Jupiter is moving counter to its described movement by all of the calculations of the astronomers? This was an interesting idea. But once I saw, night after night, with mounting excitement, I realized these could not be fixed stars, by very definition. No, they moved with Jupiter. They orbited Jupiter. And this is a very elegant argument for those who do not like the idea, who will accept with tranquility the notion of a sun-centered universe, that all of the planets move around the sun, but cannot accept the fact that only the moon will circle the Earth. Well, now we have not 1, but 2, and with 4 satellites traveling together with it around the sun in a progression of 12 years, together, and rotating and orbiting. Indeed. Of course, I named them for the Medicis. You need to get ahead in this world.
Indeed, your next observation, I believe, is my favorite of all, the phases of Venus.
Oh.
Would you describe this one?
Oh, see. Yes. Well, the Ptolemaic view of epicycles, of course, is foolishness. It makes no sense at all. Nothing in nature moves in this way. So, upon viewing Venus one time in October, I noticed that it was a nearly completely spherical bright point. No detail could I discern, but to see that it was completely lit up, that by itself made a lie of the Earth-centered, a lie of the Earth-centered idea. Ptolemy is wrong.
Now, this is something that I consider really amazing. The phases of Venus may not seem like the most exciting observation, but do you understand why, when he observed the phases of Venus, he actually proved that there was no way the Ptolemaic system could be right? Let me show you why. I have a sun model here for you. And when I was teaching astronomy, I really tried to bring this out because I think it is an incredible model. So, con permiso, padrone.
Oh, I will just stand here. Perhaps someone can bring me up a chair. I will be your audience.
Let's say that your view is the Earth. You are the Earth looking toward the sun. Remember, Ptolemy observed that the planet Venus is never seen very far away from the sun in the sky. So there was a line connecting the sun to the Earth, and both Mercury and Venus epicycles centered on that line. Now, so here's the sun and here's the Earth. Venus must always be in between the two of you. So when you see Venus as it orbits around, and I will slow this down, at this part of its orbit you see about half of Venus illuminated. As I move it into this part of the orbit, Venus is dark. As I move it around to this part of the orbit, again you see a crescent. And as we move around where Venus is closest, keep it out of the spotlight, again Venus is dark. So Venus should be seen going from a dark Venus to a crescent Venus back to a dark Venus. That wasn't what Galileo observed. Galileo observed Venus in a full phase. which meant that Venus had to be on the other side of the sun. Do you understand that? So as soon as he saw Venus going through that full phase, the Ptolemaic system was disproved. There was no way it could work in the way it existed. Venus was shown to have to orbit the sun. Not everything orbits the Earth, and in fact the Ptolemaic system does not work at all for these observations of Venus. This, in a sense, was the real nail in the coffin. Easily, he could show through his telescope that Venus and Mercury went through phases that didn't match the model. That simple. It was done. We no longer had to wonder whether the Earth was in the center. Padrone.
I believe that is what I said. No, seriously, I don't need to be here.
I apologize, Padrone. I wanted to show you some of the things that we have done to honor you. I invited you all the way here, and in appreciation, as you know, this is a strange court of people. I know you have not been in our land before. And I wanted to show you some of the things we've done in your honor. Con permiso.
Amen.
We have some telescopes here that I think would impress you. To begin with, there is the king of the gods. There is Jupiter through one of our telescopes. Now, this telescope is very special. We actually sent this telescope out into the heavens on a ship, on a special ship. This photograph was taken by a ship called Cassini. And as Cassini actually flew by Jupiter, look at the wonderful detail that it caught. But that's not all. Perhaps you remember the moons. The moons that you saw turn out to be worlds unto themselves. This is a moon of Jupiter called Io. That was the innermost one, the innermost of the Medicean stars. Io turns out to be a planet worthy of any explorer's dreams. That little blue glow there, have you heard of the Aurora Borealis in the north?
Yes.
That's the Aurora Borealis of Io. Those are the northern lights of Io, taken by the Cassini spacecraft. I'm sorry, this was taken by the New Horizons spacecraft, but don't do it. Now those moons, those Medicean stars, this is what those stars look like close up. They really are more like the moon. And I think that you will appreciate, Padrone. You called these the Medicean stars. I honor that. We have renamed them the Galilean satellites.
Well, of course.
The Galilean satellites hold a wealth of mystery for us. There is Io, there is Io, Europa, Ganymede, and Callisto. Now, Io, as I mentioned, is an amazing world. The colors. This is a volcanic plume, a volcano going off. Io has volcanoes going off all the time. In fact, at NASA, we study different volcanic basins and how they change. We observe these huge volcanoes erupting all the time. You found this world. You were the first person, the first human ever to lay eyes on Io. And here's Europa. Europa looks like a ball of ice, and we believe that this is ice on top of a liquid water ocean. There are deep cracks. The ice appears to shift. And we now wonder if, in fact, there might be life in the ocean underneath the ice. We know something is happening. There are evidences of springs that warm the ice up and form these little pockets and these beautiful deep grooves. This is Europa. You were the first person to see Europa.
I believe that is what I said.
And then, to honor you even more, this is the special ship. It's a funny-looking ship, I know. But we built that ship here in this strange court you find yourself in, and we sent it out to Jupiter, and we named this ship Galileo. And that is just a little of what we can do to thank you for what you did, for the trouble you took, and for the way your telescope revolutionized our view of astronomy.
These are very, very pretty paintings. I thank you. Grazie. But I do not believe it.
What can I do to prove it to you?
That is a longer conversation. But you would not have me believe something simply because someone told me.
I would not. It's the best question anybody can ask.
Let it go.
With that, Galileo Galilei and I are open to your questions. Can we answer any questions? That was such a clear presentation of Galileo's ideas. Everybody is fine. I really do love Galileo. It's an amazing historical person. And
I'm not married.
Such an honor to have not. That's true. He never did marry Maria de Gamba. There's a question back there.
She married to someone else.
Did.
Hi. When you were talking about the story, the history of Galileo, you mentioned there was the dialogues that you wrote using the name Simplicio. This kind of brings up, the main point of the talk, I think, obviously, is to get information out about science and exploration. But the political issues that we come across in that exploration and dealing with those, there seems to be, I've been here at JPL for 8 years, and there are constant reminders and such a responsibility to take science in a responsible, with integrity, addressing concern, and using intelligence, having scientific merit, making sure you do that process with extreme diplomacy. When we break that down, which is what, you can consider it making fun or using any sort of bullying or intimidation practices in our scientific quest, that's when we have our resistance. So do we not have, as scientists, some sort of responsibility to the science itself to present material that way and to avoid the kind of resistance that we're going to get?
I'll put a name on it. Yeah, so one of the things that I do is, you remember some years back, the Kansas School Board had decided that evolution was not something worthy of being taught in the schools. NASA sent me to talk to the school board. And I agree with you that the idea of diplomacy, the idea of, not being the arrogant scientist, can often be a very important cultural thing. At the same time, as scientists, we do need to be absolutely clear. A lot of times they would say to me, teach the controversy, teach that some people think that evolution is right and some people think that creation is right. No, there's no controversy about evolution. There's plenty of scientific controversies about what exactly happened. Exactly how one thing evolved into the other, how much did the climate change, how much was a continental drift. There's lots of controversy, but there's no controversy that it happened. And so you have to be able to say with a strong, smiling, non-judgmental face, I understand there are cultural differences, I respect your views. However, if you're going to call it science, the argument stops there. There are diplomatic ways of doing this, and Galileo unfortunately found that when you're not diplomatic, you run into trouble. I mentioned that assayer. The assayer was the pamphlet that he wrote about comets, where he did not think that comets were distant objects. He was very, very biting against the Jesuit astronomers. The Jesuit astronomers had supported him. So in publishing the assayer, he made a lot of people mad that had been on his side. So while that anger is not useful, I think it is also useful for scientists to say, observation is real, there are things we will defend and we will not really mess about with. These observations are real, he shouldn't have had to apologize for them. The politics were difficult, and we're the same way. I agree with you, it can often be a difficult line to walk.
But the truth is never the wrong answer. Perhaps I could have put it a little bit more, less bluntly. But it is difficult for a man of exceeding gifts to suffer fools gladly. And I say this in humility. Because these things are not open to debate. The Milky Way is not something filmy in the sky, it is stars.
But you're contradicting yourself because you had to debate that point yourself, so it is open for debate.
I did not debate. I present my truths, and they are, of course, true. You present your arguments against the man who is perhaps a bit more simple and misguided. Not everyone is able to reason well, as I have said. You cannot find yourself or make yourself a slave to ignorance. You cannot kowtow to a way of thinking which is bound to drag you down into darkness and back into barbarism.
was just wondering, during the talk, you emphasized the importance of publication, especially in Galileo's time period. How did scientists back then find each other? I mean,
Letters.
more than just writing letters?
Letters.
So-
We found each other. Kepler is a very good man. I regret I never sent him a telescope
He did ask for one. Kepler really wanted one.
many times.
He made his own eventually. The amount that people corresponded is something that in our day and age, I mean, I guess you could liken it to email. The letters that we have that Galileo wrote, for example, we know that he was writing his daughter, and that was just one person, a fairly insignificant person in his political life. And we have reams of letters that went between the two. The letters with Kepler, the letters between the Pope. It reminds me of the time whenever I read a Jane Austen novel and you realize how much care and time people put into writing and how much communication was going back and forth. I think to us, with the technology we have, it's like, how could they even breathe without all of the cell phones and eBay and all of that? But they were in quite a bit of communication. There was a lot of post going back.
And at that time, you must also realize we valued eloquence and the use of language. It was an art. And art was as important to the man of learning then as the science.
Well, with that, I think we will leave you. And now that we've answered your questions, I must introduce a great friend of mine, John Higley. I should mention that John is doing this as a personal favor. I thought it would be interesting to hear things from Galileo's own mouth. And John really doesn't know very much about astronomy. So the research he's had to do in order to talk about, like Galileo, in order to answer your questions has been substantial. So thank you so much, John.
Now the difference between a quasar and a supernova.
All right. Thank you very much and good night.
Adios.